Hi everyone, let's solve 155 questions on stoichiometry. These are questions that are selected from 1978 up to date. And if you can solve all of these questions, I'm 100% sure that you are going to solve any question on calculation in chemistry that they give you in your exam hall. Because you solving 155 stoichiometry problems and you get to the exam hall, you are not going to see more than 2 or 1 question. So that's why I want to solve this. So even if you probably do not have prior knowledge of stoichiometry before coming to this video, I promise you that you will understand stoichiometry at the level that it is. Just make sure that you follow what I do step by step and you will understand it. I've been teaching this class for a while now, but even if you have never watched any of the previous videos, with this video and with these questions, you'll be able to solve all questions on stoichiometry. I promise you that. Pinky promise. So let's go on. So I've selected from 1978 all the JAMB pass question that has to do with stoichiometry. So these are the points to note. You need to know that 1 mole of a substance contains what we call the Avogadro's number of particles. Just like when you say 1 dozen contains 12. If I say 1 mole means that I have 6.02 times 10 raised to the power 23 times of that thing. If I say 1 dozen, it means I have 12 times. Shey you get? That's what that part is talking about. Just know that for now. All of these are just some important conversion that you need to know, but that's not a problem. Now, write this down. These are the formulas we're going to be using to solve all the 155 questions. I'm going to solve them one after the other as you follow. So these formulas are very, very important. So let's go on. The first formula says that number of mole is equal to mass over molar mass. Number of mole is equal to volume at STP over molar volume. So depending on what they ask you to calculate, if they say calculate mass, then you're going to use the first one. If they say calculate volume at STP, you use the second one. If they say calculate concentration or anything or number of particles, you know the formula to pick out of these 8 formulas that I've written here. So let's move on to the questions without wasting time. Question 1 says that the number of atoms in 1 mole of a substance is, we just left that page. How many atoms will be present in 1 mole? How many atoms will be present in 1 dozen? That's 12. So how many atoms will be present in 1 mole? That's 6.02 times 10 raised to the power 23. And that value is also called what? Avogadro's number. So just note that. Anytime you hear that 1 mole of a substance, it contains what we call the Avogadro's number of particles. 1 mole is the simplest unit we use in chemistry. So let's move on. Number 2. What volume of 1.5 molar solution of potassium hydroxide will contain 0.045 moles? This question is asking for volume. What were you given? So you are given concentration of potassium hydroxide, which is 1.5 molar. And what else? You're also given the number of mole of potassium hydroxide. So the number of mole is given as 0.045 mole. So now, if the number of mole is this and concentration is this and you have to calculate volume, which formula are you going to use? So let's check. I have concentration and I have volume. I have number of mole. Then I want to know volume. Then I'm using equation 3, right? So let's use formula 3 and see if we'll get our answer. So now that I know concentration, I know this. Then I'll say that number of mole is equal to concentration times volume over 1000. So volume is going to be number of mole times 1000 all divided by concentration. And the number of mole is 0.045 times 1000 divided by 1.5. So if you check that out, the answer should be 30 cm cubed. Because this will be 1, 2, 3. That's 45. 45 divided by 15, that's 3. You know, this is 15 times 10 raised to the power minus 1. So if minus 1 comes up, that becomes 30. So your answer is 30 cm cubed. So let's check that, number 2. So our answer is 30 cm cubed. So let's move on to number 3. So number 3 says that, so first is just know what they ask you to look for and pick a formula. That's all. 56 cm cube of a gas at STP, weight 0.11 gram. What is the vapor density of the gas? The question is, what is the vapor density of the gas? Which formula relates vapor density? Molar mass is equal to 2 times vapor density. So you first write molar mass is equal to 2 times vapor density. I'm looking for vapor density. That means I need to know molar mass. So let's move on. Was I supplied the molar mass? No. Look at it. We said 56 cm cube at STP. So they gave you volume at STP, and that is 56 cm cube. And they now give you mass again. They now say mass of the substance is 0.11 gram. So if you are given mass, you know you want to know molar mass. Which formula can help you calculate molar mass? Very good. Number of mole is equal to mass over molar mass. That's your first formula. So now, do I know number of mole? No, I know mass. And I want to calculate molar mass. So how do I determine number of mole? Then I will use this. So I will say that number of mole is equal to volume at STP, which is the third formula here. That's the second formula here. Volume at STP over molar volume. So the volume you are given at STP is 56 divided by molar volume 22,400. So if you are given the volume in cm cube, then you will use 22,400. If you are given in dm cube, you use 22.4, but now you are given in cm cube. So you now say 56 divided by 22,400. That's that's equal to 2.5 times 10 raised to power minus 3 mole. So at the end of the day, you already know number of mole. Can you determine molar mass now? Therefore, molar mass is going to be mass over number of mole, and the mass is 0.11 divided by this number of mole, 2.5 times 10 raised to power minus 3. So if you do that calculation, that's 0.11 divided by answer, that's 44. So that's 44 gram per mole. So at the end of the day, the molar mass you have gotten is 44. So how do you get the volume now? Now that you have molar mass, now that you have molar mass, how do you get the vapor density? So that means that molar mass that is equal to 2 times vapor density. So the vapor density is going to be molar mass divided by 2, and that's 44 divided by 2, and that's 22, no unit. So now the answer is 22. Voila, that's number 3. The answer is B. So number 4, what volume will 0.5 gram of hydrogen occupy at STP? What volume will it occupy at STP? What question is that? That's saying that calculate what? Volume at STP. So which formula will you use? Formula 2. You can see that it's very simple. You just need to know the formula to use and apply it, and that's all. So we want to know the volume at STP. And to know volume at STP, then you now write that formula. So you're going to say that number of mole is equal to volume at STP all over molar volume. Shey you get? Now, you will know molar volume because it's a constant, and the unit you have is in dm cube, so you use 22.4 dm cube. But now, how do I know number of mole is the next question. The mass is 0.5 grams, so you now say that number of mole is equal to mass over molar mass. Shey you get? And what's the molar mass for hydrogen? 2, and that's going to be 0.5 divided by 2. 0.5 divided by 2, that's going to be 0.25 mole. So the number of mole of hydrogen is 0.25. So how do I get volume at STP now? My molar volume is 22.4. So number of mole 0.25 is going to be volume at STP over molar volume, which is 22.4 dm cube. So that will now be 0.25 times 22.4, and that's 5.6. So the volume at STP is equal to 5.6 dm cube. So do we have that in the option? That's option B as well. So you can see how we solved it. They said that what volume will 0.5 gram of hydrogen occupy at STP? So volume at STP, then you know the formula to use. That's the first thing. How do you get there is the next question. I need to know number of mole and I need to know molar volume. Molar volume is a constant, 22.4, but you are not given number of mole, but you are given mass. They know that you can calculate number of mole from mass over molar mass, and that's it. And when you get that, you slot it into your equation. Is it simple? So number 5, a metal M forms 2 types of chloride, MCl2 and MCl3. Which of the following laws best explains the relationship between the chlorides? Now, we have what we call law of chemical combinations. We have the way things combine. There's a part that we call law of definite proportion, law of constant composition, law of conservation of mass, law of multiple proportions. So whenever you now see that the ratio of one atom to another atom, one atom has a constant ratio but another atom is changing its ratio, then that is called multiple proportion. So now in this case now, ratio of in MCl2, M is 1, Cl is 2, 1:2. In MCl3, M is 1, Cl is 3. So the constant mole of M is the same, but chlorine keeps changing. So that is what we call law of multiple proportion. So our answer is C. Number 6, the volume occupied by 0.4 gram of hydrogen gas at STP is, so we want to calculate volume of that looks like number 4, so I leave that for you to solve. Please leave the answer in the comment section, and if you're here to subscribe, please do. We're going to 155 questions and we're going to be solving these questions together, and I'm sure that if you can solve all these 155, even when you get home at night, you can just quickly sit down, solve all of these questions, then stoichiometry problem is done before we move on to other problems too. So that is that about that. So the answer to number 6, you should drop it in the comment section. So number 7, consider the reaction represented by the equation below. XNH3 plus YCl2 to give ZHCl plus N2. The values of X, Y, and Z are respectively. So now, this is, they want us to balance the equation. That's why they put X, Y, and Z. And in the previous classes, I already taught how to balance equation by inspection or by simultaneous. But if you do not know, that's not a problem. What you are going to do in this case is that you will take, when you say a balanced equation, the atoms must be balanced on both sides. Number of nitrogen here must be balanced as with the number of nitrogen here. So nitrogen here is 2, then nitrogen here must also be 2. So you can put 2 at the front. Don't change the subscript. That's going to be wrong. So put these 2 now. Just put 2 at the front where X is. Then nitrogen will become 2. Hydrogen will become 3 times 2. That will be 6. So hydrogen becomes 6. Then that's balanced. Then chlorine from there will also become 6. Then you now say, and that will be 2 times 3. That will be 6. So chlorine 2 will also be 6. So your answer is 2, 3, and 6. All you can just do is put the equation, put all of these values at the front and check if the atoms are balanced. That's what you're going to do here. Number 8 says that the correct balanced equation for the reaction between aluminium metal and A2SO4 is. Now, in this case now, whenever you react aluminium with A2SO4, you're going to get aluminium sulfate, water, and sulfur 4 oxide. They have given you already. They just want you to balance the equation. And if you check, option A says that 2 aluminium is here. Where's my mouse? So I have 2 aluminium here, then 2 times 6, that will give me 6 hydrogen, then 4 times 6, that's 24 oxygen. So check oxygen, 3 times 4, that is 12, plus 6, that's 18, plus 3 times 2, that's 6, so that's 24. So if you now check again, so if you check, how many sulfur do I have here? 6. The number of sulfur here, is it 6? 6 here, then 3 here, then 3 here. So option A is correct. All of the atoms are balanced for option A. If you check for B to the rest, it won't be balanced. So number 9, 3 copper plus this gives this in the equation above. The values of P and X respectively are, so in this case now, they want us to calculate the value of P and X. We were told that 3Cu plus pH is balancing equation, just like what we did in 7. Just put option A, put option B, put option C, push option D, and check if it is balanced. That's all you need to do here. But the answer is D if you have gotten used to that. So you can check it out. Put the equations there and put those values, the coefficients, at the place they are supposed to be and check. So 8 and 2 will be the answer. So now number 10, what is the amount in mole of hydrogen gas that will be produced if 0.6 mole of HCl reacts with excess zinc according to the following equation? So in this case now, what we want to do is you're going to balance the equation. So the equation says that Zn plus HCl, I think there's 2 here, to give ZnCl2 plus H2. So if you check now, their ratio is 1 to 2 to 1 to 1, meaning that if this is 5, this will be 10, this will be 5, this will be 5. That's what that is telling us. 1 to 2, 5 to 10, she gets something like that. So now, you are now told that to calculate the number of mole of hydrogen gas, you are told that HCl is 0.6 mole. If HCl is 0.6, what do you think hydrogen will be? Very good, that's 0.3 mole. shey you get, because the ratio is what, 2 to 1. Just divide this by 2, then that will give you for this. Do you understand that? That's what this part. We have learned how to balance equation. We have even solved complicated problems more than this in the previous classes. So if you want to check through the previous classes, you can check through them. But if you want to follow, just keep following what we are doing right now and you get it through. So now, these are the first 10 questions. We want to solve 155. But in order for the video not to be too much, I'm going to stop here. Then I'll move on to the next 10. This 10 now, I want you to solve it before the next class. This makes 20, this makes 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 55. So we're going to 155 questions. So there is what we call primax. This is primax physical chemistry. All these questions, 155, are actually in primax physical chemistry with their solutions. If you can lay hands on them, fine. But if you can't, just solve them from the YouTube video. I'm still going to solve everything with you. So what I want you to do for me is, please, the 10 questions, I already solved the first 10. So I want you to solve the next 10 and try them on your own. Just apply the formula that will work for it. And if you're not getting it, I will solve it in the next class. Solve the ones you can solve. Anyone you did not get, you can ask someone. So these are the formulas you're going to be using to solve them. I already solved this first 10. So you solve the next 10. Then at the end of the day, if there's anyone you're not getting, I'll come and solve all of these 10 again in the next class. So please, make sure you subscribe to the channel to continue to get updates and on the notification button. And we'll continue to do well to help you out. So God bless you. I'll see you in the next class. Thank you.